All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.7 in Pre-Calc. This is the fourth video in this section and also the final video in this section. So sometimes we're given a composition of a trig function and an inverse trig function. We'll walk through some examples with numbers like this one and also some with variables. So we're going to evaluate this by hand and find the exact value. So the first thing we have to recognize is that the output of an inverse trig function is an angle. So I'm going to call that angle theta. So essentially what this statement here says is that if arcsine of -3/4 is theta, then that's the same thing as saying that -3/4 is the sine of theta, right? I can draw that triangle, right? I can draw this. So we're going to draw this triangle knowing that this is the opposite, which the negative does have to be with the opposite. It can't be with the hypotenuse. So it's the opposite over the hypotenuse. And also knowing that arcsine has an output that's in the two quadrants that are to the right of the y-axis. So I'm looking at something down here in quadrant 4 because my sine is a negative sign. So that's the y value is negative. My hypotenuse is a 4, and here's my theta. I need to find this missing side that I'm going to call x. Notice that this is not a 3, 4, 5 triangle because to be a 3, 4, 5 triangle, the x and y, or the legs, have to be the 3 and the 4. And the hypotenuse has to be the 5, and that's not what's happening here. So I can find x by saying x squared plus -3 quantity squared equals 4 squared. I'm going to get x squared plus 9 equals 16. So x squared is a 7. And normally I would say that that means x is plus or minus root 7. But again, notice where we are. Because the output of arcsine is in these two quadrants, the x value has to be positive. So I now have a triangle that has a root 7 as the x, that has a y value of a -3, and has a hypotenuse of 4. So now what I'm being asked to find is tangent of this angle theta that I have. Well, if I look at my triangle, tangent of this angle theta should be the opposite over the adjacent, and that's my answer, but I'm probably going to rationalize it, right? I'm going to get a -3 root 7 over 7, and that's it. So again, I'm drawing the triangle. I'm understanding that the arc trig function, or the inverse trig function, is actually an angle as the output. So let's go ahead and do another one for P12. So you're going to evaluate this by hand. We're going to, again, label that this is an angle, right? So this is saying that essentially theta is equal to the arcsine of 4 over 5, which is the same as saying sine of theta is 4 over 5, right? So this will be my opposite, and this will be my hypotenuse, right? I know the output of an arcsine is in these two quadrants, right? So if sine is positive, it's going to have to be here. So I know the opposite side is a 4. I know that the hypotenuse is a 5, and this one is a 3, 4, 5 triangle, so that's nice, right? Because the 5 is the hypotenuse. So I want the secant of that thing I called theta. Well, secant is going to be, so just a reminder, the secant is the reciprocal of the cosine. So instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. So this is going to be a 5 over 3. And that's my answer, right? All right, so now let's do one that has an x. And we're going to go ahead and do 2 of these that have an x involved. So we're going to write our trig expression as an algebraic expression, meaning there's no trig in it. Fully simplify your answer. It shouldn't say fully simplify your answer twice. I don't know why it says that. All right, so again, I'm going to do the same thing where I call this an angle theta. So I'm saying theta is equal to the arc sine of 2x. Now, when you're using a variable here, you should just go ahead and draw it in quadrant 1. It's too complicated to, you don't know enough about x to know what quadrant you're in. So sine of theta rather equals a 2x. So I'm going to go ahead and label my theta. Now remember that sine is actually a 2x over 1. So I have my opposite is a 2x, and my hypotenuse is a 1. So here's a 2x, and here's a 1. And then I'm going to find this missing side, right? So this missing side is going to be 1 squared minus the quantity 2x squared, right, equals, and I'm just going to go ahead and call this s for side because I've already used an x in this problem, so I can't use that. So side squared. So I'm going to get that this is the square root of 1 minus 4x squared. I don't need the plus or minus because I'm drawing in quadrant 1, right? So I'm going to get that this side is the square root of 1 minus 4x squared. So now this is the cosine of the thing I called theta. Well, the cosine of this triangle that I was given is going to be a root 1 minus 4x squared all over the hypotenuse, which is a 1. So my answer is just a root 1 minus 4x squared. All right, let's do one more. So again, I'm going to label this inside guy as my angle theta, right? I'm assuming when I'm drawing thetas where the angles involve x's that I'm just going to go ahead and draw stuff in quadrant 1. So theta equals the arc cosine of x over 3 is the same thing as saying the cosine of theta is x over 3, right? The other reason to pick quadrant 1 is because you remember that an arc cosine has an output that are these two quadrants, and if I go back here for a sec, an arc sine has an output that are these two quadrants, right? So quadrant 1 is always fair game, which is why it's safest to use quadrant 1. So when I draw my angle, right, I know that the x is going to be the adjacent, right, and the 3 is going to be the hypotenuse. So when I draw this, here's my theta, right? The x is my adjacent, the 3 is my hypotenuse. That means this missing side is the square root of 3 squared minus x squared, or just a root 9 minus x squared. So now I have my three sides. I want the tangent of theta, right? Well, the tangent of theta is going to be the opposite, which is the root 9 minus x squared, over the adjacent, which is an x, and that's my answer. And those are algebraic expressions that don't have trig. And that's the last video in this section.